Hello everyone, welcome back to one of our cybersecurity videos. My name is Mina and I'm IT technical support specialist. And today we are going to talk about how to secure connections in your company between the headquarters and the branches. So I've created a video before on how to create this one on Packet Tracer, so I can show you how to secure a connection between branches. Unfortunately, with the limitation of Cisco Packet Tracer, it does not allow me to run today's commands on Packet Tracer. It has to be run on an actual devices, which I don't have right now. But let me just explain to you the whole environment and what do we do here with this video. So basically, let's assume that you have a company, headquarters, and a few branches, branch 1 and branch 2. For simplicity, I'm just using 2 branches for now. These 3 buildings are separate buildings and all connected to the internet, and they are not connected to each other. So what we are going to do with this video today is I'm going to show you how to secure a connection between all 3 buildings, all HQ and 2 branches, and secure everything between them. Then all the computers should see from one building to another through the internet. So each building will be connected to the internet, but they are not connected to each other. So it's called hub and spook design. Connect all branches to HQ, which is the hub, and each branch is called a spook. And so the company works as one network. The goal to keep HQ is a central controller, which is the hub, and make the connection secure, stable, and easy to troubleshoot. Scale easy at branch 3, branch 4, branch 5, and repeat all the same templates here to a new branch if you have a new branch, or if you have more than 2 branches. Whatever I'm going to say here apply to all branches, because what you're going to do to one branch, it's the same, it's just gonna change a little bit with the network, subnet mask, subnets, stuff like this. The concept is connect hub and spook. HQ is the hub and branches are the spook. Each branch build one tunnel to HQ. Branch to branch communication is not allowed by default unless HQ permits it. So HQ will be the main source of allowing and denying all the connections between branches. Phase 1, pre-check before any VPN works. You need to ensure WAN and routing are stable. Tunnel cannot be stable on an unstable WAN. You need to run show IP interface briefly, show IP route, so you can see all the information and you can ping the IP address of the ISP next hop. Phase 1 is build overlay GRE hub and spook. Objective to create a scalable overlay that makes routing between sites simple. So on HQ router, you need to tunnel to branch 1. You need to do these steps. We've already done this on the previous video on how to set up the environment for testing. So we've done all of these already in a previous video. And then tunnel to branch 2, it's the same. And then you repeat this pattern for any additional branches if you have more than 2. Now the branch spook create tunnel back to HQ. So on branch 1 example, on the router from branch 1, you need to do the same, create the same tunnel with the source and destination to the HQ router. Same on and then you need to do the routing. So on HQ router, you need to route between branch 1 and branch 2, and this is also done in the previous video. And on each branch router, you need to do the router between HQ and the router itself. Then you do the verification, which we've done in the previous video. All of that we've done it in a previous video. So you can now ping from branch PC to HQ PC, from HQ PC to branch PC. On phase 2, this is the stuff that it's not allowed in packet tracer, Cisco packet tracer. So this is the security or the secure of the connection itself. And because of Cisco packet tracer limitation, I cannot run these commands. So I'm just going to explain it to you. All of that is done in a previous video, all of these steps. So, in real production network, GRE itself is not encrypted. So we need to secure it, something called GRE over IPsec. So once you create that tunnels, all network going in and out between the buildings are not encrypted. So this is not secured at all. So you need to secure security parameters, which is IKE in phase 1. This is encryption AES 256 and integrity SHA 256. Diffie-Hellman group 14 lifetime. These are all the specs of the security itself. And then phase 2 IPsec over data, still the same AES and SHA, PFS enabled, and so on. You need then to implement steps, define interesting traffic, configure IKE phase 1 policy, IPsec phase 2 proposal and transformation. These are explaining what is happening or how we are going to secure it. Then you jump to phase 3, reduce attack surface, or look down to WAN itself. Objective, allow only VPN related traffic from known peers. So if any hacker can get into the network, adding more malicious routers and try to send and receive some extra traffic from his malicious router itself, it will not work. You need to allow the VPN itself going between known peers. And still the same, these are the specs of the security. Phase 4 will be central control. HQ is the brain. If the business required branches must not communicate directly, enforce via routing or firewall policies, allow branches to talk to HQ only, and deny branches to branches traffic. So this is phase 4. Let's go up again to the picture so I can explain it a little bit. So branch 2 will talk to HQ, branch 1 will talk to HQ, HQ can talk to branch 2, can talk to branch 1. But branch 1 cannot talk to branch 2. If you want to talk it, you need to allow it. If it's not the case, like these machines cannot or do not see the machines from the other buildings, then you do not allow traffic between our branch 1 and branch 2 and so on. So the whole idea is HQ itself will control the traffic going in and out, and when there is a request between branch 1 to branch 2, HQ will disallow it or disable the connections. Let's go back. We were in number 7, phase 4 here. So as I said, if the business requires branches must not communicate directly, you enforce this via routing and firewall policies. Allow branch to talk to HQ, but deny branch to branch traffic. And then from here, these are all the steps itself that you are going to do on each router. So the router on HQ, you are going to run these steps. And this is where it's not allowed on Cisco packet tracer. So once when I tried these commands on Cisco packet tracer, it gave me an error because it's not allowed. It's not enabled in Cisco packet tracer, but it will work on the real physical routers itself. and these are all the commands that you need to do to start defining the security between the tunnels and what's going, the traffic going in and out, and it will be secured. And then this is phase 2, as you can see, and then crypto map, 1 entry per branch. These are all the technical commands that you can copy and paste or modify it according to your network. And then step 3, apply IPsec on branch 1, still the same. And the next one will be step 4, apply IPsec on branch 2. You're securing all the branches and then bringing the VPN up from PC branch 1. You can ping and start do the testing that machine from branch can talk to HQ, and machine from the next branch can talk to HQ, but they cannot talk to each other. And then on HQ, what you are going to do exactly, and then HQ1 ACL, you need just to copy the commands as it is and just change to your networks and subnet mask according to your requirement. And then you do ACL on branch 1, ACL on branch 2, and then you do some troubleshooting if you have a problem. So I've tried to write all the steps in details as much as possible. Unfortunately, I couldn't show you the simulation on how to do it, but everything is written here, as much details as possible. And again, you can see it on our website. So let me show you the website itself. Okay, so if you go to any browser and open cybersecureworld.net, and if you want, just search for Hop and Spook. You'll find it here. This is the design that I told you about. This is the configuration on how to build up the network, and these are the setups that I talked to you today. If you open this one, you will find all the information that I just mentioned on the video here, with all the technical commands that you need to do, starting from this one, because your WAN are up, tunnels are up, and routing between LANs are working. And then these are all the commands. So all you need to do is just follow up with the steps, modify it to your environment. Thank you for watching, and wait for more videos.